Where did the Yosh man go? Another field trip?
Yeah, this fresh field trip. Thing.
What? No.
Yeah, they're all
on SBLA.
No,
They're all here.
video.
Video.
Oh.
Yeah.
You know what? If that field trip is more important than my class, who am I to say?
Oh my god. That was nice. There's a tank.
I don't care. This happens at this school every year. They have all these stupid field trips and then they want the kids to perform highly on exams. I have the okay to do a review on the 26th. You guys need to tell me when you would prefer to have it. I would like an answer for tomorrow.
I can have it all day.
I want you to tell me when you would like me to have it. I don't want an answer now, I want it tomorrow.
Hello. How's it going?
That's going well. Yourself?
Pretty good.
Stay home.
Yeah.
I don't have anything Saturday. It's just
The exam
Yes. Have me
For-
account now.
Nice.
equilibrium, I just want to show you
I go to 26 on the first one. On 30.
what I did with the exam.
Yeah,
The exam was out
You're probably
of
not
47.
Yeah, probably.
Is it okay if I talk now?
Yeah, sorry.
Okay, I'm just checking. The exam was out of 47 points. Scores ranged from a high of 47 to a low of 8. Two people had 8s, one person had a 16, one 17, one 18, one had a 25, one 30, two 33, two at 36, two at 39, etc., etc. So what I did was I calculated what the actual percentage was of 47 out of 47, and that was 100. And a 46 would be a 97.8, etc. So I did the following, being kind. Of 40, well, let's just go right here. At 42, you should have had an 89.36. I made that a 90%. At a 37, that should have been a 78.7%. I called it an 80%. And I just went on 2% each time. So people got extra points that they did not earn. For example, the people that had 8, and those were probably more gift points than anything else, should have had a 17%. I gave them a 22. I raised them by 5%, or half the letter grade, sort of. So they got
That was
66 out of 300. Yes, that did have a deleterious effect on their average. But as I gave you all the problems prior to the exam, and I gave you all the answers to the same set of problems, if you chose not to study them and or learn how to do them, you were successful at failure. and the people up here were successful at learning. So that's how I did it. Eventually, you will get those tests back, and you will have the opportunity to check to see if I owe you points. Because in some cases, I had no idea what the hell people were attempting to do, so I didn't give any points for it. I gave you points where I felt you sort of earned them. Okay? Now, what occurs at the anode?
Oxidation.
Oxidation. The thing that gets oxidized is what? The reducing agent.
Yeah.
I'm going to show you something kind of slick up here before we start in on slides. And do this right away. Zinc can be oxidized to zinc ion, and I'll produce 2 electrons. Does that make sense? Another way of writing this is red, the reducing agent, will become an oxidizing agent and produce electrons. What is zinc? Metal, elemental. It's the species that's getting oxidized. Doesn't that make the zinc elemental the reducing agent? So the red forms the oxidized species and an electron. At the anode, you're always going to form the oxidizing agent and produce electrons. At the cathode, you always have reduction occurring. The species that is reduced is the oxidizing agent. So we can write oxidizing agent will gain electrons and become a reducing agent. Got it? If you know this, there's a whole lot of electrochemistry just in those, that little bit of stuff. Are we good? Now, I was told that I may have too much junk opened up. Good word. I don't have any other crap open. Quick review of the terminology again. Oxidation is the loss of electrons by a species. There's an increase in oxidation number. Reduction. See, I can't use this at all. I have no idea. Oxidation is a loss of electrons. Reduction is a gain of electrons. There's a decrease in oxidation number. The oxidizing agent is the guy that accepts electrons. Look! Ox plus an electron. Ox plus an electron. And the reducing agent is the electron donor. That's the species that is oxidized. The reducing agent becomes an oxidizing agent and produces electrons. So these reactions can go either direction. We did this, we did this, we talked about this, we did this. Okay. This is the first thing I want you to really take a look at. Kill the lights, please.
All of them?
Sure. if I place a piece of copper metal into a silver nitrate solution, I'll find that I will make little fuzzy caterpillars on the copper rock. And the fuzzy caterpillars is the silver metal. But what has to occur, if I look here, this is the silver nitrate solution prior to any reaction occurring, and I only see +1 cations here. For the exchange of electrons, the silver ion must migrate and contact the copper atoms at the surface, the elemental copper. When this occurs, I'll start to produce some +2 cations. Eventually, all that will be left in solution are the copper ions, and virtually all of the silver ions will have plated out as silver metal. Okay. Why does the silver have to migrate to the surface of the copper?
Because they actually have to exchange the electrons. Like the electrons aren't going to flow through the water. to
The electrons
ions.
can't move through the water. So you must make that physical contact for the process to occur. Does that make sense? Okay, so we're going to look at this half reaction mechanism again. So let's look at the oxidation of copper. So we do, and the reduction of the silver ions. So what I'm going to do next, balance each for mass. They're balanced. Balance each half reaction for charge by adding electrons. So I need 2 electrons here and 1 electron there. Then I have to balance out the electrons so that they're the same on both sides. Then I add them together, and I get the overall equation. But that's not that too terribly painful. We're now balanced for both charge and mass. What we really want to look at is, let's look at what's going on here in VO2 +1 ion. What's the oxidation state of the vanadium in that?
5+.
Plus,
So,
plus,
five.
+5. When I convert that to VO2+, what's the oxidation state of the vanadium?
6+.
4+.
Yeah, 4+.
Oh,
VO2+,
VO.
the vanadium is +4. I can take vanadium from the +5 oxidation state to the +4, to the +3, to the +2. What do you notice about that?
Color.
There's fewer
Each one has a
oxygens.
different color.
Yeah.
Okay, that has to do with how many of the d orbitals are occupied and how electrons can jump. If I'm in an acid solution, what do I have lots of?
H+.
H plus and what else?
H3O.
That's the same thing. What else?
Or.
No, not if you're in an acid solution, you
No.
chucklehead.
Conjugate A.
No! If I'm in an acid solution, what do I have lots of? H
H
plus,
plus.
right? What else do I have lots of?
Ions floating
No.
around.
Oh. A-.
What is the predominant other species in
A-.
What?
A-.
No!
Water?
Water! Water is 56 molar. Okay? So you always have lots of water in an acid solution. You always have lots of water in a base solution. You always have lots of water in a neutral solution as long as all the solutions are aqueous. All right? Is that clear? All right. I want to balance this reaction in an acid solution. And then we're going to do the daughter of all equations. So my two half reactions, one of them is this going to that, and the other one is the zinc elemental going to zinc plus 2. Once I have the two half reaction, I have to do a mass balance. Well, this one's really easy. One of those, we're done. For this, I've got a problem. I have more oxygens on the reactant side than I do on the product side. So to balance for mass, I'm going to add water to the side that's short oxygen. And then now I've got 2 hydrogens on this side, none on that side, so I'm going to add 2 hydrogens to that side. We've used H plus for simplification. This is just bookkeeping. If you want to write H3O plus, you can, but if you do that, then you have to have more waters over there. Okay? Are we mass balanced now? Yeah. Are we charged balanced? Well, this is 0, this is a plus 2. So I need 2 electrons over here. Here I have a, this is a plus 3 on this side and a plus 2 on that side. So what do we have to add?
Electrons to the one.
Yeah.
1 electron to the reactant side. When we're doing these, we add water to the side that's short oxygen and H plus on the other side for hydrogen. And to balance the equation, we have to multiply by an appropriate factor. Then we add them up, and then we can double check. Are we okay? Everything is peachy keen. Never add O2 O atoms or O2 minus to balance oxygen. What do we add to balance oxygen?
Water.
Water. Never add H2 or H plus atoms to balance hydrogen. Be sure to write the correct charges on all the ions. Check your work at the end to make sure mass and charge are balanced. Here's the hard part. I can't do that for you. It's called practice. I mean, I can do all the problems for you, but that won't transfer any knowledge. Okay, so what we're going to do here I want you to get out the daughter of all equations. And I'm going to show you how you use oxidation states method to solve that.
Why not the mother of all equations?
Because I don't feel like doing that right
Oh, they're different things? Okay.
You have the answer for them in front of you.
Do you know which page they're on again?
The correct
Oh, the one that says daughter of all
Daughter of
equations.
all equations.
Wow, they actually call it that. I thought it was just something you came up with.
Something, they got the mother of all equations, and that's getting a little dicey for me. So, what's the reaction? HIO3?
What?
Can you?
HIO3.
So what's the rest of the stuff?
FeCl3 plus ICO plus H2O.
Okay, the first thing I've got to do with this is go in and assign oxidation states to everything. What's the oxidation state on the oxygen and water?
H plus and
2 minutes.
What?
H plus.
What's the oxidation? You don't listen when I talk. You answer the question you want me to ask. What's the oxidation state on the oxygen in water?
2 minus.
What's the oxidation state on the hydrogen?
Plus 1.
What's the oxidation state of chlorine and ICl?
Minus 1.
How about the iodine? Hello.
Hi. Sorry, is it okay if we work on a lab in the back right now?
What are you doing, the penny thing?
It's the one with the little black boxes. Mrs.
Oh, I don't care.
Is in the back. Sorry, thank you.
Make lots of noise so you distract my students. They don't want to pay attention anyway. So that's plus 1, right?
Yep.
What's the oxidation state of the chloride in FeCl3?
Plus 1.
Negative.
Minus.
And the iron is,
Plus 3.
the Cl is,
Minus 1.
and the hydrogen's,
Plus 1.
and the I is, this is,
Negative 1.
and the iron is,
Plus 2.
it looks like it's minus I, and I don't want to confuse anyone. So the oxygen here is a,
Minus 2.
and the iodine is a,
Plus 5.
and the hydrogen's a
Plus 1.
plus 1. Do you have any questions on how any of those were obtained? If you can do this part, you can do oxidation states method. So what's changing?
Yeah.
Okay, so this goes from plus 5 to plus 1. How do I go from plus 5 to plus 1?
Gain 4 electrons.
Gains. Four electrons. Okay. What else changes?
Actually loses an electron.
Okay, iron goes from plus 2 to plus 3 by, it loses how many electrons?
Plus 1.
Loss of 1 electron. Okay, what else? What else is changing? Look a little closer.
All of the iodines changing from minus 1 to plus 1.
What's it? How do I go from minus 1 to plus 1?
You lose 2 electrons.
Lose
2.
a total of 2 electrons. Okay, I lose 2 electrons, right? How many I minuses do I have, minus 1s do I have here?
2.
2, so what's the total loss?
This 1. 4.
3. How could you possibly come up with 3? Because that was the next sequential number I was hoping. I did it in first grade all the time, and it worked. Look, each I minus 1 to go to plus 1 has to lose 2 electrons each. 2 electrons each for a total of
4.
So 4 electron loss total. Okay, now, how many electrons am I gaining?
4.
4. How many am I losing?
4.
5.
5.
Oh, right. Yeah.
My total loss is 5. You with me to there?
Mhm.
What's the common multiple?
20.
20. So I have to lump these guys together and multiply this by 4, and I've got to multiply this one by 5. So that takes me down to rewriting this equation. So, what do I have to multiply HiO3 by? 5. What do I have to multiply the FeI2 by? 4. So now I'm going to start to balance. Now I will start to balance. Where do all the I's end up at?
ICO.
In the ICO. How many I's do I have here?
5.
And here?
8.
And 5 and 8 is 13. That's not a B, that's a 13. Okay, so now I got 13 of so that's good. That's good so far, right? Right? How many irons do I have?
4.
How many do we have over here?
1.
1, so I need a 4, right? Well, look, Shazam! I only have one source of HCl, correct? So let's figure out how many chlorides or chlorines I have. 3 times 4 is 12, and 13 is 25. So this has to be a 25. And let's see, I got 25 hydrogens, and 5 hydrogens is
15.
30, so this has to be 15. And if you look in that packet, those are the coefficients, and that's how you find them.
How'd you get the
Magic.
5s again? Is it because you still have like the lingering
What?
+1 charge
How many electrons am I gaining?
between?
Before the multiples is 4, right? How many am I
you get 4
losing?
there.
5. What's a common multiple of 4 and 5?
20.
So what do I have to multiply the 4 by to get 20? 5.
Yeah.
What do I have to multiply the 5 by to get 20?
Oh, you
4.
added the loss of 1. Oh.
You have to, the
Okay.
total
That's
loss of electrons has to equal the total gain of electrons. And if you look at the mother of all equations, there's all kinds of things being oxidized and reduced. So it's more of a seeing through what all is changing, because you got a whole bunch of, it isn't just one, there's one reduction, but there are 2 oxidations here. Okay, 2 species are being oxidized. Or you can think of it as one species, but it's occurring in 2 steps. Do you see how this works? Is this impossible to do? Did you want to see another one? What's the next one? The sun?
The sun.
What's the sun?
CuSCN
CuSCN.
plus KiO3 plus HCl.
KiO3.
Yep.
Plus HCl. Copper sulfate
Yields copper sulfate.
plus potassium chloride
That stuff.
plus
Hydrogen cyanide.
acid plus ICl.
What?
Iodine chloride.
ICL?
Yeah.
Yep. And water.
Iodine monochloride.
What?
What is the charge on SCN?
0.
No.
Wait.
I didn't put the copper in. I said, what's the charge on
Oh.
thiocyanate?
Oh, -1. Always -1.
Okay, if this whole thing is a -1, the most electronegative element is nitrogen, and nitrogen would be assigned a,
-5. No. Yeah. Oh, naturado.
how about -3?
Yeah.
Okay. Wait a minute, you don't have any carbon over there. Oh, yes, you do, never mind. And C, and you, okay, so this copper has to be a +1, right?
Yeah.
Yeah.
What's the least electronegative thing up there, sulfur or carbon?
Carbon.
Carbon.
Yeah.
Carbon. Carbon.
It doesn't matter. What oxidation state do you want to assign?
C would be plus.
What?
Carbon would be plus. Carbon would be plus.
Okay, it doesn't matter.
Oh.
If I call this a +1, what does the sulfur have to be?
+1.
Plus one,
A
two.
+1. This is just bookkeeping. As long as you're consistent, you're fine. The potassium's a +1, the oxygen's a -2, so the iodine is a +5. +1, -1. +2, -2, +6. +1, -1, +1. Cn is a -1, so the nitrogen's a -3, and the carbon's a +2, +1, -2, -1, +1. Now, what's undergoing change?
Copper.
That's a loss of 1 electron, right?
Yeah.
Okay. What's the sulfur doing?
Losing.
I'm
Losing
going
five.
from +1 to +6. So how is it losing?
5.
To go from, yeah, never mind.
5
To go from +1 to +6, I'm going to lose what's carbon doing?
Carbon is losing 2. 1.
No, only one.
I said losing 2, that T-O-O.
This is a +2.
Okay.
This is a +1, right?
Yeah.
Yeah.
To go from +1 to +2, how many electrons do you lose?
1.
Nitrogen loses 1 also.
How do you figure?
No, it doesn't. I mean,
Ion.
Okay, that's it. I have a nitrogen as a -3 there and a -3 there, right?
yeah.
Okay, what's the,
The I.
Ion.
I'm going from,
+5 to +1.
what do I do in going from +5 to +1?
Gain forward.
Okay. Anything else changing? What's my total loss?
7.
7. What's my total gain? What's the common multiple?
What,
28.
wait, what about the oxygen? Does the oxygen?
Oxygen's -2 everywhere.
Right.
There's no change.
Okay.
Does anything else change oxidation states?
Nope.
So I have 7 and 4, so my multiple is 28. So I have to multiply this guy times 7 and this guy times 4. So I'm going to write 4 CUSCN plus 7 KiO3s plus HCl gives me CuSO4 plus KCl plus H2O plus ICl. So now I'm going to do the same kind of thing
You forgot
here.
HCN.
What?
You forgot HCN.
No, I didn't. I just didn't write it to see if anyone was awake. Okay, I lied. Now, what I'm going to do here, I only have one source of copper, right?
Mm-hmm.
So I've got to have 4 coppers over here. Hey, I only have one source of sulfur, and that's 4, so that worked, right? Now, how about carbon? How many places do I have carbon?
1.
One.
So that 4 has to come here too. Look how cute that little 4 goes there. How nice. Look, it's so cute. The little 4 goes right there. Now, how many sources of I do I have?
One.
So this 7 better come over here. And how many sources of potassium do I have? 1. So this 7 better come over here. Now, everybody, okay, I don't have my hydrogens taken care of yet, but what am I going to take care of next?
Chlorine.
Cl. How many Cls do I have?
7.
And 7 is 14. Now, how many hydrogens do I have?
2.
4. 5.
What? You have 14 on the left, 2 on the left. No, you don't have 2 on the right. I lied. You have 6 on the right.
Okay, look.
You just need
How many hydrogens do I have on the reactant side? 14. How many hydrogens do I have on the product side?
4.
4 and then
4. And to make that 14, I have to make this a
5.
5.
Make it 5. Everything's balanced.
Now, let's count oxygens. 4 times 4 is 16, and 5 is 21, and 7 times 3 is 21. It's magic, it's balanced. Is it rocket science?
No.
Just have to do bookkeeping.
Yeah, that helps. Thanks for doing it.
Yes.
What happens if you make the S and C plus 4 minus 4?
Then
Would
it
you have a
would
different
it's
multiple?
still going to work.
But you would have a different multiple, right?
What?
Right.
You would have a different multiple.
No, you wouldn't.
Because the common OP.
It all works out.
Then try it out.
As long as you figure it out.
Yeah.
I'm done. No. We don't want to say that. This is where I don't know how to do that from here. I don't know how to right click on this. I'm not sure I know how to right click on this either. Where did we leave off at? This slide.
Next slide, I think.
So we already went over
How
this.
many slides in?
We did this slide.
No.
Okay, this is where we left off at?
No, we did this. We did the next slide. We're on chart. We're on
done
slide
with the
17.
tips on there. Let's see. So we're on 19.
Oh, yeah.
That's where I was. But I was rudely told that, did we do this?
Yes.
Yeah.
Okay?
Yeah.
You finished 18, so.
No. Okay, let's just do the TIPSCO room again. Never add O2O or O2 minus to balance oxygen. Never add H2 or H atoms to balance hydrogen. Be sure to write the correct charges on all ions. Check your work at the end to make sure mass and charge is balanced. And then you got to practice. I can't do them for you. I wish I could, then everyone could get a 5 on the AP exam, or we would be like the best thing since sliced bread. But that's not going to happen. If I place zinc metal into a solution that contains copper 2 ions, what's going to happen?
Ion and copper metal.
I'll make zinc ions and copper metal. Am I going to produce any electricity by doing that?
No.
No. Where does that exchange of an electron have to occur at?
Surface of
The surface of the zinc metal. It's very much like the silver ion reacting at the surface of the copper metal. Okay? With time, the copper is going to plate out onto the zinc metal strip, and the zinc strip is going to get smaller. Because I have zinc metal forming zinc ions plus 2 electrons. And I have copper ions gaining 2 electrons to get copper elemental. What is copper 2 in this process? The oxidizing or the reducing agent?
Reduce.
No, oxidizing agent because it's getting
Oh,
reduced, 'cause it's
agent,
getting
yeah,
electrons.
agent, yeah.
Look,
Oh, it's so confusing.
oxidation is always going to occur at the anode. In this case, zinc is getting oxidized to zinc ion. The reducing agent gets oxidized and produces electrons. At the cathode, I have reduction. Here, copper 2 ions are gaining electrons to form elemental copper. So copper 2 ions are the oxidizing agent, gains N electrons to make the reducing agent. Electrons are transferred from the zinc to the copper where there's no useful electrical current. This is the reducing agent forming the oxidizing agent plus N electrons. What does the oxidizing agent undergo? It's reduction. So the oxidizing agent gets reduced. The reduction, that has to be the oxidizing agent because the oxidizing agent undergoes reduction. It's always written ox plus N electrons yields red. Here I have ox plus N electrons. There's my reducing agent. Do you see how the oxidizing agent is always on the side where the electrons are? So in this process, this is my oxidizing agent because it gets reduced. This is my reducing agent because it gets oxidized. If I write this reaction in the reverse direction, what is zinc ion undergoing?
Reduction.
So that makes it the
Oxidizing agent.
ox plus N electrons yields red. If I write this in reverse, what's the reaction?
It's undergoing oxidation.
It's undergoing oxidation. So this is the oxidizing, this is the reducing agent forming the oxidizing agent and electrons. The guy gaining the electrons is being reduced. The guy losing electrons is being oxidized. That's the reducing agent. There's your overall process. If I want to get useful work out of this, we need to separate the oxidizing and reducing agents so that for the electron transfer to occur, they have to travel through an external wire. Now, this has always bugged me about this. Can I go back to the stock room and find a bottle that only contains zinc ions? What else will that bottle contain? The anions. Thank God someone in here knew that. I thought maybe I told the other class that you could just go back and get a bottle of ions. So this isn't showing me what the counter ions are. There's something else associated with these guys. The way this works, this has to be the anode because I've got electrons going through this way. Got it? So that means that this zinc metal is producing zinc ions and electrons. So the zinc is the reducing agent. Here, the copper ions are consuming the electrons at the surface of the copper metal to become more copper metal. So this electrode's going to get bigger, this one's going to get smaller. And then we have the mysterious salt bridge. Let's confuse students. If I don't have this salt bridge here, okay, and I hook this up, as soon as one electron goes this way, what's going to happen to the charge in here? It's going to become excessively positively charged. Okay? As soon as I use up two electrons on this side, what's going to happen to the charge over here?
It's more negative.
It's going to become more negative because I've removed the cation. It's going to have a net negative charge. That circuit's going to stop because it's not complete. I'm going to have charge imbalance. The purpose of the salt bridge is twofold. It completes the circuit. Can you get the light bulb to come on if the circuit isn't complete? No. So this gives me a completed circuit for travel of negative things. Now, electrons can flow through the external wire, and as soon as I consume a cation, what do I have an excess of? Anions. So anions are, what charge are they?
Negative.
So they're going to flow through the circuit this way to complete the circuit. Okay? Now, if I'm consuming a cation over here, what do I have a shortage of? Cations. So cations are going to want to go the opposite way. You can think of them moving too. Okay. And if I'm producing zinc over here, what do I have an excess of?
The anion.
Cations. So they can move that way and anions can move that way. They both happen at the same time. But it's completing the electrical circuit. Does that make sense to you? And what's occurring over here if electrons are flowing that way? Oxidation. What is being oxidized?
The zinc.
The zinc metal is getting oxidized and becoming zinc ions. What does that make the zinc metal? Reducing agent. What is happening over here?
The copper ions
Are being
reduced.
reduced. Okay, that makes the copper ions the oxidizing agent. Remember how I wrote it? Ox plus N electrons yields red. That identifies it. This is accomplished in a galvanic or voltaic cell. A group of such cells is called a battery. Electrons travel through this external wire, and the salt bridge allows anions and cations to move between the electrode compartments to complete the circuit and keep charge imbalance from happening. So I have charge imbalance, nothing's going to flow. Does that make sense? Okay, here at the anode we have oxidation of the zinc metal. So that means that this is red, forming the oxidized species and N electrons. This is the reduction, and that's occurring at the cathode, and this is assigned a positive charge in a galvanic cell. But let's look at what this is telling me. If this is undergoing reduction, doesn't that, what species is this then?
The oxidizing.
That's the oxidizing agent. That's why we write it ox plus N electrons yields red. So copper 2 is the oxidizing agent because it gets